Hi, welcome back to another episode of Algebra and Words, the video series. In this episode, we're going to start talking about linear equations. Alright, I have three type of things that I want to cover in a very basic form to start off in our introduction to linear equations. First of all, there's basically two types of linear equations. I'm sure you know by now a linear equation makes a straight line on a graph. I'm not going to get too much into that, but we will get into the details as we go forward. There's two general types of linear equations. Those with one variable and those with two variables. A horizontal line and a vertical line are the type that are made with one variable in the equation. We're going to look at that briefly in a second. Another type is the type with two variables. That would be a diagonal line. So let's start off with some basics on a horizontal line. I have an equation for a horizontal line and also for a vertical. Let's start with the horizontal. And I have a graph on the board which we're going to use to graph the horizontal equation. There's something I always start off explaining to my students with regards to horizontal and vertical lines, which is something that I always say is a little contrary to your logic when you're starting out. Okay? And I'm just going to come right out and say what that is. When we think of horizontal line, we think of x. Why do we think of x? Because the horizontal axis, the x-axis, is a horizontal line, and we attribute that with x. It is the x-axis. However, when we're dealing with horizontal lines are defined by a very simple equation. Y equals a number. Okay? I'm going to explain that in a second, but before we get to that, if we compare, usually students get accustomed to diagonal line linear equations. This one is in the form y equals mx plus b, the slope-intercept form. That's the form that students I've encountered are most comfortable with. And so, that being said, students usually kind of expect all linear equations to take on this form. That's true for diagonal, but not for vertical and not for horizontal. These equations are so simple that it almost may go under your radar because it looks like it's just an answer to a problem. X or y is equal to a number. But that does represent a horizontal or vertical line, respectively. Let's start with y equals 5. Okay, and before we draw the line, let's just find y equals 5 on the graph. So we'll start at the origin, and it's positive, so we're going to go up. Let me change markers. We're going to go up 1, 2, 3, 4, 5 units. And let me just draw a dot there for a second. Now, this is going to be a horizontal line. We already know that, but suppose you didn't know that, okay? Do this. Draw a line that goes through every possible point where y equals 5. Well, that would be here, that would be here, that would be here, 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 and so on. You don't have to draw a million dots, but that's just to exemplify that if we were to find all the places on the graph where y equals 5, it would be all those places that makes the horizontal line. So, in summary of that, when you're plotting a horizontal line, make sure that it's y equals a number. Don't mix it up with x. Start off by just finding the point on the graph, starting at the origin, count up or down, put your pencil or whatever there, and then just draw the remaining part of the line. Okay? And if you need to think about it more, just say to yourself, you could actually think of what the points are. This point would be 0, 5. This point would be negative 1, 5, negative 2, 5, negative 3, 5. This would be 1, 5, 2, 5, 3, 5. They all have 5 as y, and that's why it makes a horizontal line. Alright, pretty easy. Let's go on to the next one, a vertical line. I just randomly made this up. X equals negative 3. Let's find x equals negative 3. start at the origin. It's negative, so we're going to go to the left. 1, 2, 3. Let's just put a dot there. And it's a vertical line, so we're going to draw a vertical line. If we were to look at the actual points, this would be negative 3, 0. This would be negative 3, 1, negative 3, 2, negative 3, 3. If we were to go below the axis, we would have negative 3, negative 1, negative 2, negative 1, negative 3, negative 1, and so on. So again, the quick summary of the quick little crash course on horizontal and vertical lines is the equation that they're defined by might be contrary to logic. Horizontal is defined by y equals a number. Vertical is equal to x equals a number. It's something you're just going to have to get practice with and basically memorize to get accustomed to it. Okay, that brings us to diagonal lines. And I have whole videos dedicated to diagonal linear equations, but just in the scope of introduction, I have this basic linear equation, y equals 1/2 x plus 3. So without getting into too much of the details, let's just plot it so that we could see a diagonal line on the graph. The 3 is the y-intercept. It's the point on the graph where the line crosses the y-intercept. So we're just going to start at the origin and find 3. Let me just get a different color marker. Start at the origin and count up 3. 1, 2, 3. Draw a point there. That represents the y-intercept. All right? We're going to keep our marker or our pencil here, and using the slope, which represents the vertical change over the horizontal change, sometimes you know it as the rise over run. Notice that this 1/2 or the 1 and 2 are both positive, so that means that we're going to be moving them in the positive direction. So back at the y-intercept, we're going to go up 1 and over 2. Draw the point. Go up 1, over 2. Draw the point, and then as best you can, draw the line through the points. And draw it all the way through as far as you can. And that's what it looks like. That's basically the intro to linear equations. Horizontal lines, vertical lines, diagonal lines. I'm going to pause the video and I'm going to put up 3 different forms of diagonal lines and we'll talk about those. Okay, welcome back. So what I have on the board is I wrote out the 3 typical forms of linear equations that you'll be encountering from here on out when you're dealing with linear equations. And the linear equations topic and chapter can be pretty extensive. There's a lot you can do with it. So let me first tell you what I have on the board. One form is called Slope-Intercept form. And the basic general form of that equation is y equals mx plus b. The next form that I have is called standard form. ax plus by is equal to c. And the final one that I have is called point-slope form, or the point-slope formula. Y minus y1 is equal to m times the group x minus x1. All right? So let's talk about these a little bit. In this video, I'm basically going to explain each component of each equation, what they're used for, and also how they relate. In later videos, I'll be putting them to actual use and doing some exercises and examples with you. But I wanted to get this out of the way first. There's a lot to explain here, and it's good to understand these fully before you move on to exercises and examples. Okay, so first let's look at the slope-intercept form. Let's look at the words slope and intercept. The definition is in the word. M, okay, and I will go over slope completely in another video, but M represents slope. The X and the Y, they're just the variables. You can substitute numbers in for them, but generally in this case, just leave them X, Y. And B is the intercept. So we have slope, which is m, and intercept, which is the y-intercept, which is b. That's the background of where that equation comes from. Now, the slope-intercept form is, I'm going to take liberties and say it's the most common form. There's no technical grounding of that, except for that usually that's the form that you'll use most and be most comfortable with. It's usually the type that students are most comfortable with. If you're given an equation in that form, it's pretty easy to take the numbers and values in that equation and just plot it automatically. But that's not the case with the other two forms, okay? So I explained what the M and the B stand for here. Let's look at standard form, all right? Now, this is standard form for linear equations, okay? But I want to point one thing out, which is as you go forward in later difficulties, particularly you'll get to quadratic equations later, linear equations are 1-degree equations, which make a straight line. Remember we talked about degree a couple videos back. The highest exponent of x is 1, even for this one, for all linear equations. When you get to quadratic equations, and even future equations, they'll all also have their own standard form. But they all have their own standard form that relates to that degree of equation or that type of graph. For linear, it's ax plus by is equal to c. If we were to just put this into words, what's this equation, how is this made? Because it's taking the x and the y variables and putting them on one side of the equation, usually the left, could be the right if it's reversed, but usually on the left. And the a and the b represent the coefficients of in front of x and y, if there are any. There may be, there may not be. And c, I think of it as constant. It doesn't literally translate to that, but in this case, I want you to remember that the variables are on the left side, and the number is on the right side with no variable. That's how you should remember this. Now, one other little detail to point out that must be fully understood so you don't get confused is, we have a b here, and we have a b here. Those b's are completely different contexts of each other. This b in slope-intercept form represents y-intercept only. This b simply just represents a coefficient in front of y if there is one, okay? Now, this form can be plotted into a graph automatically, but this form cannot, and this form cannot. Whenever you're given a standard form or a point slope form, or if you have to convert into those forms, these cannot automatically be graphed. You have to convert these into the slope-intercept form if you want to graph it from the equation. And finally, let's look at the point slope form. Again, the definition is in the name. We have the point and the slope, okay? Now, let's look at the variables in this, because we have y and y1, m and x x1. This is what I want to point out, and I tell this to all my students, which I think is helpful. This y and this x should stay y and x. Never change them and never substitute numbers into them. Sometimes you'll substitute numbers into this x and y or this x and y, and that's fine. There's situations for that. But when you're dealing with a point slope formula, the purpose behind that formula is you're given a point. You could be given more points. I'll go into that in a later video. But you could be given a point. You put the value of x in for x1 and the value of y in for y1. You might have the slope. You put the slope in. But you leave x as x. You don't put a number in for that. And you leave y as y. No number in for that either. Because once you do put the variables in, put the values in for x1 and y1 respectively, and do the rearrangement, it will ultimately come into this form, which if you notice has y and x as it is. You also see the m here. Sometimes the m is given, the slope. Sometimes you have to solve for the slope depending on how many depending on what you're given and how many points you're given. I think that pretty much summarizes this. One final thing that I want to say before we go on, I think is an important point, is in this form, if you have slope, it does represent the actual slope, okay? In this form, when this m is in front of x, it's the slope, it's the functional slope. However, don't confuse the coefficient in front of this x in standard form with m, because this is not the slope. You can't get the slope in standard form unless you rearrange this into the slope-intercept form. Also, if I really had to give you a purpose of the point-slope formula, the point-slope formula's purpose is, again, usually if you're given a point and a slope, the overall purpose of it is to substitute those numbers in, rearrange it, and put it into this form. Depending on the type of practice problems that you're given, like in the book or on a test, the question might direct you into what form to convert either form into. So, and there's various reasons and situations when you would do each. You do what the question asks. But ultimately, the function of a point-slope formula is to substitute in values that you have and convert it into this form so that it can then be graphed. Alright, so that concludes the little intro video on linear equations. I will be going over this various topics much more intricately in future connected videos, which I'll have listed. Anyway, thanks for watching. I hope you found it helpful. If you did, please give a thumbs up. Please subscribe to the channel so you can be alerted to future videos. And please especially share with your friends so that they can share in this knowledge as well. And also feel free to leave comments below. Thanks for watching, and I'll see you next video.